Okay, so hey everyone. Before anyone joins, I'm going to probably let's see if we can't share my screen. Um, let's see. Uh, I think the good part is maybe just some quick updates on what has happened recently. Um, we've put out a new newsletter. We're talking recently. We were at ML4H, and basically, enlarging this so the view doesn't look weird. But basically, we had three papers this cycle that were accepted to ML4H. We did quite a variety of different works. Here's our kind of cute team dinner with the Sun Lab and the PyHealth guys. Here's one of our cool posters that we've had about a benchmark for prostate cancer, which I think I'm very proud of. Here's one on SDOH, which is actually named as one of the talks as one of the most important things we should be looking at in terms of EHR. So they have a lot of SDOH codes um, that we should be looking for, and we investigate how well LLMs are good at picking out these codes, whether or not we can do properly identify these codes in advance. Um, they also go through a variety of benchmarks and models. Uh, let's see, as well as they kind of look at what is the performance across different types of different types of SDOH conditions. We also have a rare disease, a very big, very preliminary rare disease work where we mined a bunch of rare diseases from clinical notes. We asked the LLM if they could actually predict whether or not that they had a patient had a rare disease given their profile. Um, but basically, we're doing an open call to the PyHealth Research Initiative to have people work with us to do very similar things like this. Basically, working on a really important healthcare problem, write a research paper, and get published. I want to say that the nice part is we do provide direct mentorship. Whether the mentorship comes from physicians, other PhD students who have been working in this field for several years. We do have industry collaborations that we're doing right now. So there is quite interesting. And so the goal is to work on specifically interesting and challenging healthcare problems. I think this is PyHealth. So if that's not what you want to do, please. At the end of the program, you ideally have gained. But basically, we'll ideally have a good amount of, you'll have basically a credible piece of work that has been verified by other people. You'll have direct hands-on experience. And then the nice part is you can also say if you can put on your CV that, hey, I've contributed to a nice open source project that does have direct relevance to other things. In terms of the timeline, we want to say that this would be something like 10 to 20 hours a week. Depending on how busy you are, how much progress you're going to make, but it helps to do this. Our goal is to work for. Oh, hey, Yongda, what's up?
Hello, how are you?
Doing all right. How about you? Uh,
I'm good. How's your trip?
yeah, it was good. It was good. I really enjoyed Japan. I didn't enjoy having to drive 8 hours, 9 hours, and then fly back to San Diego the next day. But it was an interesting experience being jet lagged at ML4H. Uh, it's yeah, I don't know. How about you? How are you? How was I know in Canada you guys have a separate Thanksgiving, right? So it wasn't really Thanksgiving for you, but it was
Uh,
Thanksgiving for us.
yeah, we didn't have that vacation for this week, so also pretty busy week this week.
Oh,
So yeah.
yeah. Hopefully, hopefully you got some rest, I guess. Um, yeah, no, I think Japan. I don't know. Have you been to Japan? I'm not sure if that's.
Oh yeah, I've been there lots of times.
Oh, okay,
Uh,
okay.
only Tokyo though.
Yeah, okay, okay. Yeah, we were in Tokyo, and then I guess there's like a hot springs place called like Hakone. I don't know if you've ever heard of it, but Tokyo is really nice. It's actually a really it's kind of it makes me feel bad about our American cities, honestly, in some ways. Very, very.
It's really, really good. I do like Tokyo a lot.
Yeah. Yeah, it's like super clean. The public transportation's really nice. The food is great. Like I don't think I was expecting, like, I don't know how to describe it. Like I've never had bad food in Ch Tokyo, if that makes any sense. Like even if I'm at like McDonald's or a 7-Eleven, like like the food quality is really good. Um it kind of yeah, it's like in the US, I feel like you have to think about where you want to eat at a restaurant, right? In Japan, I feel like you could walk into anything and like not really feel bad afterwards, you know? Um,
Yeah.
hey Andrea, it's been a little bit.
Yeah, been a couple weeks actually.
Yeah, sorry, I was gone for Thanksgiving. Um,
Oh, no
uh,
worries. I traveled myself, so I was can't say I really did a whole lot over Thanksgiving. Mostly just lots of eating, bit of cooking.
yeah, food's good. Food is. I think yeah. I was in Japan, so the food was the main thing I was interested in, and I'm not disappointed. So,
And
um,
had some amazing food.
I guess if we're gonna use this meeting wisely, I guess Yongda, I was gonna go talk to you about the. I haven't had the time to like ever since I gotten back finally to look at the memory stuff.
Yeah.
Do
Uh,
you?
so,
Yeah, so go ahead.
so currently there are two approaches. One is the MAM5 branch, which use the Dask, and another is MAM7. I haven't created a pull request for that because it's not yet fully complete, but that use Progress.
Okay.
So it turns out that the memory issue we are encounter on Progress, aside from we didn't catch that, uh, was uh so the lower version of Progress have bug on joining table, so they will calculate the incorrect memory usage for the table joining, and then
Okay.
do not spell the table when they need to. So I think with the latest version, that problem is fixed. Then we can actually use the progress to do that, and the ultimate thing will be we want to cache in the middle, and
Hmm.
then we run an iterable data set at the end, which if we use lead data, which is the thing I'm currently using for this branch, then it also support like random access, just a bit slower, not
Oh,
significantly slower, only a bit slower than like sequential access.
okay.
Um, uh, uh, but I do think we should do some benchmarking between. I
Hmm.
mean, it depends. If we think Progress is good, like in terms of API or something, we can go with Progress. But if we want to see the performance, we may want to still benchmark the two different branches. So I think Progress is significantly faster in terms of um, like a single CPU like processing capability.
Yeah.
But Dask can utilize more cores better in a way.
Okay. Okay.
So yeah, I guess it depends. So I think
Hmm.
because the benchmark you see like the link you sent me, they say like they use the thread version for the Dask, right?
Yeah.
And so thread version is basically because the GIL, thread version basically means like they can have some level of parallelism, but not significant because ultimately when they go back to Python, there's a global lock to ensure that everything is synchronized. Um,
Hmm.
so one thing that um Dask is able to do is use its distributed backend, like to create a local cluster in a way that it can also like be a distributed cluster, but for a single machine, it's a local cluster that can utilize all the cores. Of course, given memory requirements is satisfied. So it can like utilize memory. Sorry, it can utilize core much better if we have like significantly more cores. Whereas
Hmm.
ProRes, because it's a threaded, there's a limit on how parallel it can be.
Okay, okay. I was under the impression that they did a bunch of like polars can still use multiple cores, right? I'm not
It can. It's just there's a so 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 for Python there's there's two things. One is the code actually run in Python, and that will be super slow. So no
yeah,
library actually use that. And
yeah.
then like there's a call to the underlying like C or Rust or whatever the fast language they are writing to.
Hmm.
Um, so the idea is that uh, the Python part have the something called GIL. So it ensures the Python part is always single threaded, unless you use the multi-process, like you fork the process or you spawn the process. Uh,
Hmm.
but the underlying C part or the underlying Rust part, those can be parallelized. But there's a limit on how much parallelization they can have because like the one that calling them, like the Python code, is single threaded.
Okay, okay, I
Yeah.
see.
And the idea of Dask is they actually like just spin up a bunch of like Python interpreter independently to deal with that. But multi-process is also like a bit tricky to deal with because it's that's not
Hmm.
the intended way to run it. It's just a hack to let the Python run like in parallel.
Yeah.
Um, so personally, I think we are if we are not like tracing like the best of best performance, I think a ProRes version should be sufficient.
Okay.
But depends on like your opinion on that.
My thought is I would like to stick to polars mostly because we have a lot of technical debt now, I think, with polars.
It may not be the technical that it's just I think because ProRes is definitely the future.
Hmm.
It's just like the Dask is like a few more years mature than ProRes.
I
So
see. I see.
like
I
say like 5 or 10 years later, no one will ever use Dask.
okay. Okay. Yeah. No, I think I was I mean, even at ML4H, one of the other things I noticed was from many of the companies that I talked to, they're all using polars. Like I don't know, I was talking to like some Amazon people and then there's this like other I think these guys are also a startup. I don't actually know, Quantco.
Yeah.
Um
Yeah, Porters is currently the best execution engine for a single machine. Like,
hmm.
or I mean, relatively small single machine. Um, no one can beat it. But when you want to like scale it up, it become problematic.
Okay, okay. I'm okay with I mean originally the memory optimization goal is so you can fit it into a single
Yeah.
machine. So I'm okay if that's yeah, it doesn't need to be the fastest. It just needs to like not be how do I say this? It just needs to not be pandas. Is my
Oh, yeah.
is
I
my
make things
opinion.
better behind this.
Yeah, anything
Yeah,
is
yeah.
better.
If that's the goal, I think we can stick with Pros, given like currently they have fixed the bug, and I hope they don't introduce another bug later
Okay.
in a different version. Yeah, and so another thing about the Plurus is that it automatically detects your system memory and try to use
Hmm.
all of them. So it's very hard to say like how much it can run on. I do test it on my like 32 gig machine and it runs fine.
Yeah.
Uh, I suspect it can run on a smaller memory machine, given just because, I think Pro is auto-adapted, assuming like they calculate their memory usage at each step correctly and then spell them correctly. Uh, but I just don't have a smaller machine to test. It's just very hard to find a 16G machine nowadays.
No, that's okay. I mean, I don't know. No, no, you shouldn't have to. I mean, yeah, I also, yeah, I don't know. I think it's okay to assume 32 gigs, like for our purposes, just because, yeah, just for time. Um,
Yeah.
I think, actually, I'm just curious. You said it was in Mem 7. I don't know where, uh, like, how did you implement this? Where are you testing this? I'm just curious.
Oh, there's a like man test or script or something, if I recall correctly, in the example.
Right here. Oh, okay. I see. I see. Mem
I,
test.
I I'm not sure if I like put all my tests here. Probably not. But because there are still some change in my local.
Yeah.
But ultimately, so most of thing is done. The only thing is, so if you check our current implementation of the sample data set,
Hmm.
you'll see that we convert the we do those like processor stuff, and then we convert our samples once, and then when we do the get item, it's already converted one,
Yeah.
right? We don't
Yeah.
recompute them.
Right.
This is very hard to simulate in iterable dataset because you can't modify what's on the disk and you can't store them in the memory. Um, so one way is we take a small performance hit that we always like dynamically compute this transformation on the fly.
Yeah.
I'm not sure how bad the situation would be for this, especially given all of our processors are Python code.
Ooh, okay.
Another
Yeah, yeah.
possibility is we first do the transformer and we first do the transformation and
Hmm.
then we cache it as the final cache, and then from that point we always read the correct data.
Oh,
I'm
okay.
trying to implement the second method because it's more
Yeah, yeah,
uh,
yeah. This was
uh,
something brought up to me by the Signal people, which is that if you have really like whether it's like really high resolution images, right, or really, really long signals, like just big signals with large wavelengths. The problem is when you do the transformation, if you have to do it dynamically every time, like to construct a whole batch, it's really expensive. Um,
Yeah. Yeah. So
yeah.
that's the thing for maps. That's something not implemented in map 5. But I'm trying
Hmm.
to do it in map 7. To just have that. So we redo the transformation and then we first collect all the samples, we save it somewhere, and then we build a processor if needed. And then we say we run the transformation and then we save another cache as a final cache we want for the task, and then we go from there. So that should be performance optimal in terms of what
Hmm.
we can get. And I don't think there's any heat like in terms of versus this version, because if the data is really small, uh,
Yeah.
lead data should be able to hold all of them in like memory. So
Right.
it's effectively the only issue is the cold start. Like they will need to first load something, but after that it should be like the performance should be the same. Because
Can
lead data basically use a LRU to keep the like their cache, and if they detect, oh, I'm about to run out of memory, they kick the least used one.
okay. Can I earlier I think like while I was like during I guess American Thanksgiving, I was chatting with you about if it was possible to keep two modes in the sense that we keep the sample data set
Yeah,
and we
I
have an
think it's
interval sample.
possible. I think it's possible, and given we can actually work with explorers, um,
Hmm.
I think currently with the new process, I think it's technically possible.
Yeah.
But I'm still not sure if that's the best approach to do that, given like
I was more
we need
thinking
to
about
maintain twice the code.
yeah, yeah. I know what you're saying. I just feel like the okay. Well, one of my fears was if we changed what the sample data set is to iterable sample data set, the at least from when I was messing around with this, oh yeah, I was also wonder if Naveen will show up today, but uh, yeah, this is all vibe coding. When I was vibe coding this. to see if like what it would even look like roughly. It felt like it is a bit more, but it would be nice to have the option to such that when people do um, like such that for the tutorials and like COVID CX19 60XR, like these really tiny data sets that really are generally just very accessible anyways.
Yeah.
That we don't have to like change any of these tutorials or mess around with the API with those. Like you can just kind of keep the
Do
legacy
we,
stuff.
does the collab have like their disk storage or something?
Oh, let me check. It's gonna be one of those for you.
Yeah, like as long as we can write something to disk, I don't think it will change any of our example. They should work out of box.
Okay, let's see.
Like they still have those random access stuff and like whatever they want to do, it will be the same.
Okay,
Um,
okay.
but the only concern is that if they don't have the like disk storage, that could be problematic.
Let's look at the resources. Change runtime. Yeah, why not?
And another thing is that for one is if we want to have different thing like the uh
Yeah, we have disk, yeah.
okay. So for one thing is that if we want to have different sample data set, that's doable.
Hmm.
Uh, and but our split method will be different for each one. Um,
Yeah. Yeah, yeah, yeah.
uh, and but everything else should pretty much remain the same. If we want to have the different API for base data set, that will be significantly more difficult. We basically need to maintain two versions of the code and ensure like they are the same every time we change one part.
I
We need to
guess
change
I guess
another.
usability wise, if we were to go all in on streaming, like we just that's all we care about,
Mhm.
then could we maintain the same API structures such that like when we 'cause I'm gonna imagine a bunch of unit tests will just start breaking like the moment.
As long as you don't try to access the internal like global event DF like directly read it or something. Like if you
Okay.
don't directly read the internal property uh of the base data set, you should be fine. Like if just calling method, I don't think there's a problem on that.
Okay. Okay. Let's try it. I'm down to keep. I would like to stay with polars. I think let's keep going. I think I actually will admit. I think even if it's like a small speed penalty in terms of processing for whatever reason, I still think it's worth it just for memory accessibility reasons. Because I
Yeah.
think because I think the how do I say this? It seemed to me while I was at M1 for H, a lot of people were really interested in this, but like the machines that they would use would maybe be like 128 gigs of memory or something like that. Like not not 1 terabyte, which I realize now is even rare amongst like researchers that are working on these things. Or it'd be like an EC2 instance, right? Like they would like rent out and then they would do the work on
Yeah,
them.
like even for EC2 instance, like it's typically like 100 gig or something. Like terabytes of memory is extremely expensive.
Yeah.
Like
So,
especially compared to like especially if you want to run GPU instance, like
right,
they
right.
need to partition that instance. Like it's typically one GPU per 12 gig memory. That's a normal situation.
Yeah.
So
Oh,
it's
okay, I see.
basically like super expensive on EC2 if you want to have like everything high.
Okay, okay. Yeah, okay. Yeah, thanks, Yongda. I think this is really big. Like actually this makes a huge difference in um, how usable PyHealth actually is. Uh, so I think yeah, I think I'm excited to see what the and I'm also okay with yeah, if we want to like yeah, I don't think we should be loading everything into memory. And I think it doesn't really make a difference for COVID-19 CXR either, right? Like if you have an image data set that you're already iteratively reading from disk anyways, it seems like the speed difference is negligible in that case.
I think it will be faster because like
Yeah.
lead data have some magic like preloading stuff to
Oh, really?
minimize the penalty of this reading. If you read sequentially, of course. If you
Okay.
read randomly, then that's different story.
For when we do, I guess when we do a randomized mode, is it possible to first randomly sampled and then cache? In some
There's always a
sense?
shuffle option
Yeah.
because what lead data save is they save in chunk.
Okay.
And then when you enable the shuffle option, they will randomly read a chunk
Yeah.
and then randomly
Oh,
read a
okay.
partition of that
I see.
chunk.
I see.
So that will like it's not 100% uniformly random, but I think
Right,
it's
right,
good enough for all the training purpose.
right. It's so that they have like a hierarchy of like here's a bunch of chunks. Let's randomly
Yeah.
pick one of these. Okay. Okay. Okay.
Yeah, yeah. So
Yeah,
like
yeah.
like there have different chunks. You randomly pick a chunk, and then for each chunk, like there are a number of
Right,
rows.
right.
You randomly pick a range,
I
and
see. I
then
see. I see.
and then that range is your like what will be emitted, and then after that they randomly pick another chunk, randomly pick another
Okay.
range, something like that.
Okay, that's good. That's like I'm yeah, I guess it makes sense people have thought about this. Yeah. I see a new
They definitely thought about that. It's
yeah.
just there's a bit change need to be done in our code that like it would be a very simple change. So uh, the get data loader part we currently like try to use the shuffle flag in the data loader, which won't work because
Hmm.
the data loader shuffle only works for like for the dataset, not the iterable dataset. So just need to change that. So when we get a data loader and we have the
Hmm.
shuffle enable, we need to first set the shuffle property for the dataset itself, and then we just return a normal like data loader without any shuffle flag. So we change the flag from data loader to dataset. That's how like
Okay. Oh, okay.
iterable dataset works. Yeah.
I see, I see. And then basically the loader every time it iterates, it just
Yeah, yeah. So
okay,
data
okay,
loader
okay.
doesn't shuffle anything. The data set itself will like when they go through the iteration, they will give the randomly shuffled sample.
Got it. Got it. Okay. Okay, no, that makes sense. Actually, I'm yeah, I'm happy to move. That's an easy fix. That's like really easy to fix.
Yeah,
Um,
and another thing is just a split because it's no longer like random. Sorry, it is no longer like random access. So we can't use subset.
yeah.
But I do have a part of code basically like modified from what lead data does to be able to like split the like iterable data set into like subset. That's also like a functionality supported by the lead data set itself.
Hmm.
So like basically both of them are doable, but like they require different code. Yeah.
Okay.
One is split, and another is shuffle.
Okay. Yeah, yeah, okay. I'm do you think from a usability perspective, like if somebody else was building PyHealth, that this would increase the prerequisite amount of knowledge to work with and modify some of the functions for their own purposes? I'm just curious. I I've
I don't think so if they don't touch too internal. Like
okay.
if they just want to give a new splitting method,
Yeah.
that's totally fine. They just need to generate a new index and then feed into the like the function.
Yeah.
But if they want to like further optimize in terms of like cache locality in my like splitting function or something like that, of course that will require like more knowledge on that.
Okay.
You can see my like mam5. There's a working splitting method. The API is very similar. It's just uh,
Yeah. Yeah. I was thinking also, but regarding like the tasks and the processors, those are probably going to be like
yeah
the same, I'm guessing. It's functionally pretty straightforward.
yeah.
Okay.
Also,
Okay.
I think it's greatly simplified because we remove a bunch of like multi. like thread stuff, which doesn't really help.
Okay.
Yeah. But
Nice.
so if you just see the split method, you see like we define a new sample subset, and then everything else just
Oh, okay.
basically
That's
sync.
okay. That's pretty. Okay, that's pretty easy. Okay. No, that's yeah. Okay, that's actually pretty readable. I don't think
Yeah, yeah,
anybody.
yeah.
Yeah,
So
yeah, yeah, yeah.
if they stop here, I don't think there's any like usability issue. But
Got it.
if they want to dig deeper, then it start becoming problematic.
Right. I, Young, I'm gonna stop you right here for a little bit. Just I see there's a new face, Navodita. Am I pronouncing your name correctly? I don't know. Um, it's nice to meet you. I
Yeah,
guess we.
hi.
Hi, I'm John. I'm the maintainer of PyHealth. This is Yangda. He's the wizard of PyHealth, as far as I'm concerned. And then this is Andrea, who's also very happily working with us as part of our interpretability team.
Thanks
Do you
for
mind introducing yourself? And then we can go around to the other two, I guess. Sorry, Andrea. I kind of cut you off right there. Uh,
no worries. I was just saying hi.
Yeah, so my name is Namadita. I'm currently working as a healthcare data scientist at a startup. So I'm familiar with information extraction as well as computer vision, and I did reach out to you about this before. So my main interest is in pathology. Yeah.
I forget, did you poke me on Discord earlier? I can't remember.
Yes, that's me. Yeah.
Okay. Yeah, it's nice to meet you. We're actively expanding things. I think pathology is I think Microsoft is working pretty big, like hugely in that space. They have like a bunch of pathology foundation models. Yeah, I don't know. Let us know what we can do. I think pathology data sets are quite massive. So I think this memory rework Yangda is basically handling for us is like a pretty big deal. I'm not sure. Yeah, is
No, I have contributed to, I was previous in the image of in the space of remote sensing actually. So that's where so I'm used to working with large data set. I think there is something known as torch lightning actually that
mm,
helped me.
yeah. I think PyTorch Lightning is I guess Yana, we're technically compatible, but we're not we don't have any good examples
Mm,
with it at this point. Um,
mm,
No,
let
for
me
me
think.
mainly I have worked with benchmarking of models actually in that space. So for me it was running and loading the model points basically.
oh, okay.
I don't think we are technically compatible at this point because we are still not inheriting from like Lightning module.
Yeah. We'd have to
Um,
you would do PyHealth and you would like wrap it somehow in an ugly manner.
yeah. If you wrap it, of course, it's compatible because
Yeah.
like we are as compatible as like PyTorch is compatible with Lightning,
Yeah, right.
not like natively directly work with like a torch, sorry, Lightning train or something.
Right. It's on the the do list of requests. I guess I don't know. I don't know where we were going with this. I guess Navodita, I don't know what kind of contribution or collaboration we can do. I don't know if you have code bases you'd like to put in the PyHealth. Yeah, we'd be happy to like work with you on these types of things. Um,
Yeah. I just haven't got around much time to look everything into it, so I'm still kind of like familiarizing myself with everything.
oh yeah, cool. No worries. We have a good amount of tutorials and examples that are actively building. I can show you this. I'm remarkably as the more examples we have in PyHealth, the better it feels like these LLMs are at like looking into these packages and extending it. So the frameworks, or at least it's pretty good at. Um,
Hmm.
yeah, currently I'm looking in
Yeah,
the chap. Yeah.
and I feel like PyHealth is very well structured, so it's very easy to work with. Like it's structured very cleanly, so that very easy to know where you want to find something.
Hmm.
Yeah, those are kind words, Youngda. I think I think it's at least very flat. I'll admit. I think that's nice. We're in some sense like I am worried as the number of clinical data sets grows, we're gonna have like I don't know if you click this button, there's gonna be like this giant this giant list. But I think it's fine for now, and I think yeah.
I think it's fine. I think one of the biggest enemy in software engineering is over abstraction.
Hmm.
So just keep it simple. So like then it's actually both good for like human to read and for like for programmers to write it. Like over
Hmm.
abstraction is sometimes like really really bad and very hard to spot. So, but when you are like over abstracting it or when you are like just abstracting it correctly. So
Yeah, yeah. That gives me a little bit more confidence. Yeah, I think actually I think interestingly enough, I got to go to the research initiative. Abraham Ariano, like this guy right here, I think yeah, this guy on the left was also talking about that. I think it was um, and so it was a really nice meeting and asking questions. I think this guy's at AWS. He was like, if you ever want to like put PyHealth and then make it security credentialed. I'm your guy, and I was like, I don't, I don't think we're there yet, but I'm happy to see the interest. I think, what was I gonna say? I think, yeah. So I will say, our documentation is getting a lot better. We have a lot of like people who have helped us make things into I don't know. It used to be that these pages had no te details about exactly what any of these things are. And now I think we have like, here's an example of processors, what they do, specifically, how they're used to transform into like tensor formats, how you can define them, the schemas, the different ways of defining the schemas. So if you want to like explicitly outline some of the arguments in your processing, types of imputation strategies, arguments, different ways of defining them. So you don't actually always have to define them using strings. You can also define them using their class objects. Um, and it's been really exciting to see. And it's really nice that people are helping us with this because I think previously people were just like it would look something like this, like this giant, this really ugly thing. But now it's like, okay, now we can give you an example on how to run using, I think this is a drug recommendation model, like specialized models, EEG models, how you might use these. Okay, maybe we need to change the examples here, but there's a lot of nice things about this. I think the big thing is now that our Discord server is increasing with the number of users of PyHealth. It used to be it used to be that I even didn't know how like what's how some of these things were implemented. And so like it's nice that there is a bigger community of people like you can ask questions. I think Yongda is probably um, has definitely been very helpful in um, explaining some of the basics of things. We also are actively doing a lot of research projects that we think are really relevant to healthcare. Um, that are basically being run by some of the people that are crazily. I don't know why Yongda and Andrea, you guys are happy to do this type of stuff, but I'm really happy you guys are. And I'm hoping we can, yeah, I've been talking to a lot of industry people who are really interested in this type of stuff. And so hopefully one day, Yongda, I can like pay you to come with me to Emily, like maybe MLHC the next year. That'd be kind of cool. Um,
yeah,
uh,
I will be more excited if I can get like more paper published.
Oh, okay, okay, okay. Yeah, yeah. Well, you're already on like oh, I should update you guys on the interpretability paper direction. I've gotten one of the physicians to give us he's given the thumbs up on the like when we build the model. I just need to get one of the PhD students in my lab that we're doing DKA predictions, so diabetic ketoacidosis. And basically, I'm going to, yeah, I will send another message out later and linking up exactly what would happen in that meeting. But basically, we'll have interpretable, the interpretability is important because the features are clinically like highly, like there's certain things that are very like glucose that are very clinically, like causally, like there's a causal relationship between some of these features. And so That'll be really good. And we do now have a physician that'll directly help us interpret. He also has an army of medical students, so if we do need to do a bunch of annotations for some reason, um, we can. But so he's given us he's like director of some lab. But yeah, so we do have a lot of open projects. I should probably go to here. We have an open projects list that we're slowly expanding. I've added a bunch of, especially with OSF healthcare. Um, well, I will say everybody who does contribute to PyHealth, there's a PyHealth 2.0 paper that I've been very slowly drafting figures for that I need to work faster and harder on as we get really closer and these bounties get filled up. But basically, I actually think this will be a really nice paper because I think we'll have solved a lot of the pains and sufferings of working with healthcare data. And it seems like how do I say this? The at the conference recently, so I've been to this conference at MFRH for 2 years now. The conference has definitely gotten bigger, and there's more and more, whether that's like companies or like academic researchers that are doing these clinical predictive models. And let's see, do I have? Okay, that's not. Yeah, I'm like drafting. I'm slowly making figures. Hopefully, we can. Um, yeah, I think when yeah, younger, I will definitely send you an overleaf, and I'm happy to put you in a bunch of these papers. That um, there's also a let's see, this is logged in now. There's also a PyHealth agent that's being built, Yongda. I don't know if you we have an open source version of this that's coming out that I need to that that my advisor is pushing me really hard on. But basically,
Oh, this is very cool.
yeah, yeah. So, yeah, yeah. So basically everything you do, Yongda. Oh, you know what's
Yeah,
funny? The sandbox. So we have like a EC2 container that's linked up to the agent. And it
yeah.
crashes because we run out of memory. So if you fix the memory issues, the agent will be able to actually do predictive modeling. Right now it can't because we run out of memory.
I see, I see.
Yeah,
Yeah, yeah, I'll definitely like work
yeah.
harder on getting that done. Like
Uh,
this is really, really interesting. Like I think this is also like really, really useful for people without much coding background to, get things done.
Yeah, yeah, yeah.
Yeah.
There's a bunch of physicians at Harvard Medical School that were like, okay. They go to my advisor like, okay, this is I like this. When can I buy it? And I'm like, and he looks at me and he's like, John, when can you actually deploy this? And I'm like, well, I don't know.
Mm.
Yeah, I will see. But so the nice part is it'll take you all the stages through the PyHealth pipeline. And it'll recommend. So the nice part is the schemas. It used to be my lab mates would be like, why the hell do I have to define a schema? Like what who cares? Like this processor task thing is too heavy. I just like doing the transformations directly. But as it turns out, it's really important for the agent. Um, to know exactly what he's doing. So it'll be like, okay, let me look for a prediction task. Okay, how do I represent this? Like multi-label, multi-class, the binary. Some of the things, the outcomes, obviously you would never want the agent to do themselves, but he will recommend like death. So we're doing mortality prediction here. And then like the input features are like yeah, they're very big. So like the nice thing is you can define them as a sequence, a multi-hop vector, like just things that you can like plug and play with the PyHealth pipelines, which is really cool. Um, and so yeah, so there's a lot of these, and then you can train the model. A lot of times the performance is really bad right off the bat, so you'll see something like your first model will be garbage, and then you'll be slowly better as you iterate with the agent. And the cool part is you can just ask the agent to do some type of feature selection and explain to you what's going on and what might be happening and what you want to do. I will say there's so okay, this is hasn't been updated yet. But basically there's going to be a PyHealth evaluation module as well. That Andrea, Yongda, you guys have been building really happily, like very helpfully in the interpretability module here. And the coolest thing I think that'll be in the future that'll happen is basically the agent will be able to take an entire pipeline. Once the model has been trained and deployed, you can do interpretability. You can do uncertainty quantification. Like you can do a lot of things that previously you would need like a data scientist or a researcher to do. And I think it's really that's really exciting to me. Um, I think the future direction of this is where I'm going to. Youngda, are you still doing the crazy Google form of like the LLM? Can the LLM, how does this LLM work with this paper?
Yeah. Uh,
Okay.
yeah. So that Google Form stuff. Actually, my teammate asks
Yeah.
most of the agent question. I rarely do.
Okay.
Uh, I'm still like a bit more traditional in that sense. Like
No, no, it's good that you are because it means you're actually verifying some of the stuff that's being like that
yeah,
you're
like the
doing.
because I did try like lots of stuff like with AI initially, but then they screw up me multiple times.
Yeah, yeah, yeah.
So after that,
Yeah.
I will still like manually verify everything because
Yeah.
you never know.
I think one of the goals originally was to build a benchmark to see if you could translate healthcare AI papers into actionable code. Your experience is very much my experience, which is this is so terrible. But it feels like maybe as we build PyHealth out and the more documentation we have, it does
Uh,
we it
I
should
I
yeah.
I think for well-known paper, it can actually do it.
Mm,
So by well-known, I mean if there's already like reference implementation somewhere else,
yeah.
uh, then it can do it. If it's a brand new paper, I don't think so.
I think my thought was it should be good enough to translate math into like tensor operations, right? Like the equations.
In theory,
Hopefully.
yes.
Yeah.
But so one thing I discovered is AI sometimes like try to be lazy. So if they realize some specific thing like require hook into gradient or like some specific scaling happens like in the middle of layers, they will move that around to make the code easier, and
Hmm.
which defeat the purpose of the original paper. And
Okay.
it's also like very hard to spot.
Hmm.
Like you need to manually because it will run just fine. And also like all those transformation is there. Like it's very
Okay.
uh like hard to find. But if you look close enough, you will see like they actually move some like they change the order of some operations so that it's easier for the AI to write code. And I think
Hmm.
that's a bit problematic because
Yeah.
the worst error is the error that never reads the exception.
Right, right. Okay, okay. In that case, that might be yeah, the original idea was like the crazy idea was we have a big reproducibility problem in healthcare AI. If you publish a paper, one of the nice things that would be really nice is if I could actually validate what you're saying is true in an automated fashion or just like a first attempt. But I can yeah, I can imagine
I think
this
it
be really
work well
complicated.
as a first attempt.
Yeah,
Uh, I mean, if the performance match whatever it says on the paper, even the method is a bit different. Like
yeah,
when AI implemented, it still like sort of verify what the paper
right,
says.
right.
And if there's a significant degrade in terms of performance, we can further investigate. I think it can work as a like a first step on the
Hmm.
replication, but we just can't fully account for it.
Yeah. Yeah, yeah, no, I agree. I agree. But I will say I feel like I don't know if you've been playing with Opus 4.5 recently. I will say it's nice to see like slow but like some things that I couldn't do before. It's just
Oh,
um
I always use GPT-5 Codex Max.
oh, okay, okay.
That's the best of best. At
Yeah.
least before Gemini 3 comes out. I haven't tried Gemini 3 yet.
Okay, okay.
But that's the best of best. But that's also the most expensive one.
He's a maximum for okay. How much do you pay for that? Like is that like do you use do you pay for ChatGPT Max or is that
I so like if you pay that like $20 membership,
yeah.
it does include some quota.
Yeah.
Uh, is sufficient for me to use 1 day per week. But after that,
Okay.
I run out of quota. If I do want to
Okay.
use it continuously, then I'll probably either need to like buy 7 membership, or need to, or need to buy the API separately. So that's still
Okay,
like very
okay.
very expensive.
Yeah, yeah. I was gonna say, I feel like
So like it's fine like for like for like part-time thing,
yeah,
just
yeah,
do
yeah.
something on weekend, that's fine. But if I use it uh like uh 7 day a week, then it would become significantly more expensive.
Hmm. I
Yeah,
will
but
admit, yeah.
I mean like during work hours, my company also gave me a different like coding
Oh, okay,
agent,
okay,
and
okay.
they pay for it, so that's fine.
Yeah, yeah, yeah. I remember when I was at Amazon, the Claude. Oh, okay. The problem was the Claude models were so overused, but they wanted people to use the Amazon Nova models. So you would wait like several minutes to get one query like for like Claude Sonnet 4 at the time, or and then like but then like if you wanted to use any of the other models they offered, it was like lightning fast, like instant response, and I was just like.
I see.
It's like, and then my friends at Meta were like, "Yeah, we're forced to use Llama." And then
Oh
they,
yeah, I think in Google they also forced to use like a modified version of Gemini.
yes, yeah, yeah,
Uh,
yeah, yeah, yeah. It's
and they also have a quota that they must use like certain
oh,
amount
okay.
of AI to code their code. Like
I
they
didn't.
can't just ignore the agent and read code by
That
their.
wasn't what I was told, but they were said like, oh, I like back when it was just Gemini 2, they're like it was awful, but then now it's Gemini 3, they're like it's so much better. Like I think there's a there's like
I think the AI is learning from like their employee, right? Coding Python.
yeah, it's
Like part of their job is to provide the way, like provide example to write, like provide training samples for writing code.
there's a part of me that's wondering, are we just like automating ourselves out of a job? You know? Like there's like a, yeah, there's like a, because there's yeah, I remember so my friend actually I can share his face like he yeah, so oh no, this is the wrong John Kim, I think. State. He's Oh, okay. I don't know. I guess he took off his LinkedIn. I guess he's finally tilted. But th this guy basically, he's part of the security teams at Google, and he was talking about how like I think they ran an experiment where like the AI was supposed to like build a bunch of the security infrastructure at Google and like completely messed up and destroyed a bunch of things. But
Oh, security.
yeah,
Like,
yeah,
yeah, it's
That's
very brave to let AI write
spicy.
security code.
I think it's just it's interesting what like they're what they're trying to use AI for and like they're finding it doesn't work on, but then there's a question of like if they're giving feedback on this and like for example they have a blue and a red team, so one guy attacks and one team defends, right? Like you
Yeah,
could imagine as the AI gets better at red teaming, the more dangerous it is like
yeah,
to other companies and other things, and it's kind of there are some like ethical boundaries here. I don't think Google is cares about, but you know, it's like yeah, my AI is really good at attacking your security, but I'm defending against my own AI, so that's okay, like kind of kind of like um anyways, yeah, so this weird
It's
things are
definitely
happening.
fun to watch.
Yeah.
I'm just sort of like taking notes from a distance because I don't work at a company that makes AI anything at the moment. So I'm like, okay, we're just following along and using whatever models people recommend. So and
Mm.
that we have access to, and they pay for it, and I don't really worry about it. So I think mostly we've been just using Claude, but if Gemini is starting to get a little bit better, that might be something to keep an eye out for. If there's other models that are coming up, I was watching the Amazon keynote this week, and they were talking about their was it Kiro, their new
Yeah.
development suite, and I'm like, okay, well, we'll have to keep an eye on that too, I guess. And then they actually had an entire keynote address where they were talking about how AI isn't going to replace anyone. There will always need to
Mm.
be developers to deal with AI and stuff like that. And that was like the entire theme of it.
I
Definitely
think
would recommend taking a look, but.
Yeah, no, I think the big thing that that people have consistently talked about specifically around like the AI agents and the coding tools and how useful they are, it seems like a lot of people are transitioning in this Claude Code slash codec slash whatever. And it seems to be more of the fact that it's been pre-context engineered, if that makes any sense. Like people, the company, like the from what I understand, Claude Code has a bunch of guidelines that are already built into it that make the coding experience a lot better. Um,
Mhm, mhm.
and it feels like maybe the future is not only like that the models are nice, but also the fact that like you're gonna have like a group of engineers that are just basically prompt tuning like like these systems to make
Mhm, mhm.
sure yeah but
They
yeah
they don't completely overhaul your security and destroy it from the inside out.
yeah, yeah. I
Their
hope
early example.
not. But there is well, I guess that the Chinese state-sponsored group manipulated. This is a thing that came out of I don't know when was this. Oh, I guess in no, mid-November that I thought was kind of crazy. Like there's a bunch of espionage groups like trying to use their APIs to to do cyber attacks. And what bothers me is like but there are clearly these companies that are making them more capable as like security experts. So it's like,
Like they AI or what was it? Amazon was talking about their new security focused agentic future agentic system.
yeah.
That was another one of the keynotes. It was like, okay, they're making all these new agentic models that they're like because they're trying to make the models that can code for days on end without any user involvement. So that was point number one that they were working on. And then they were doing
hmm
like dedicated models for different applications, and security was definitely one of them, which I thought was a little bit scary, honestly.
Yeah, I can't wait for all these legacy governments to get absolutely destroyed by the the number of cybersecurity attacks that are going to be increasingly better at doing cybersecurity attacks. Um, I don't, yeah, there's a part of me that's definitely like, okay, I don't think governments are really like they don't, how do I say this? I think there's a lot of people that are very skeptical about how good these systems are. Or those able to use 94 to 80% without, yeah. So like, but the fact of the matter is, there's definitely this aspect of, um, yeah, like people are skeptical, but I haven't seen the progress curve flatten at all. Like it feels like things are still moving along, and so. Um, it definitely, I don't know how to describe it. Even if there is an AI bubble, it doesn't change the fact that we haven't really
Yeah.
paused in terms of progress, which I think is kind of scary. Um,
Yeah. Well, that was my other takeaway is that Amazon feels like they're coming up with new processes to improve the AI systems, and they're not seeing it slow down either.
yeah,
So
yeah.
I think that the little hiccup where everyone's like, oh, ChatGPT 5 isn't really better than ChatGPT 4, and that sort of hiccup that maybe gave some mixed signals of it pausing or slowing down was maybe slightly overstated.
Mm, I think ChatGPT
We'll see.
5 is better than 4, but not
hmm
like normal, like daily conversation. Is like what 5 significantly strengthen is the like reasoning part. Like they like especially like writing code, solve math problem. Like those uh thing really improve a lot compared to 4. So I feel
Mm.
like you can't
So,
expect a new version to be better than old version on every single metric, right? There's always like
right.
improvement on certain direction, but not others. Like depends on what they are focusing on.
I think what's crazy to me is we're like, like GPT-3 was what, 2024, like the preview release. So it's been 3 years ago. And like if you use ChatGPT like 3.5 at the time, like that was already kind of like a magical moment. And the fact of the matter is like nobody says GPT 3. Like GPT-5 is worse than GPT 3.5. Like there's like clearly um
Clearly growth. And I
yeah.
think, Yanda, you bring up a really good point of it
Yeah,
just depends a lot on the application. Because I feel like there's going to be these sort of branching applications where AIs get more and more focused on each of these specific spots and how good or bad they are for that. I think I think we're seeing a lot of like specialization, and maybe that's the future
Yeah.
of the AI models is just
Yeah.
more and more specialization of like, okay, there's going to be the model for everybody who wants to do advanced Google searches on the internet with their Chat GPT, and then there's going to be all like the Claude and the various agentic like software engineering models, and we'll see what other industries start really getting deep on the AI
Mm.
bandwagon because I feel like those are sort of the two big applications I hear about right now, but I feel like there's a lot more incoming.
I think the big thing. Oh, sorry. Go ahead, Young. I'll let you talk.
Yeah, I think currently the academia is more transitioning into transitioning into like a small language model, which is
Yeah.
a smaller version of large language model. Like they are more interested in that because currently the cost of large language model is like unprofitable given their like training costs, electricity, those kind of stuff.
I've noticed personally that there's this 3B model, like this open source 3B model class that's just like super popular now. It seems like a lot of smaller industries, like whether it's companies or just different teams at different companies or academia. Yeah, it's just specifically like a certain size that's just large enough that you can do some special things like reinforcement learning with, and you can suddenly start doing a lot of tasks that like 3.5 or O3 mini or DeepSeek can't really do all that well comparatively. So like this is I don't know for I think this is doing clinical task about calculations like clinical calculations and like just because these models are supposedly they claim they can do certain mathematical operations doesn't mean they're actually going to be good at them, specifically in the clinical sense. And so there's people are training these smaller models to do these types of EHR reasoning tasks. Um, and yeah, this is a shout out to Jatsung in this paper. Um, although I will admit, I feel like academia, the review process is quite broken. I thought it was funny. He was telling me he got really good reviews for this, and then uh, I guess when we do submit a paper, it's not surprising to get like reviewers that are really positive about your paper, but you still get rejected anyways because there's just too many papers and it's too noisy. But uh, yeah, I think this would be a cool future direction with the agents. Like, can you do a reinforcement learning trained, really hyper efficient, um, a clinical coder or something? But there's also a lot of questions if this is even worthwhile doing if the mini models are getting better.
Maybe
GPT.
that helps with some of the environmental concerns that are starting to really bubble up, and a lot of people are really complaining about is these LLMs taking up all of that. You talked about like the electricity and the water and all these other resources that we may or may not be able to afford to feed into them for fancy Google searches. So maybe maybe that is sort of the future is smaller models that are more efficient because I feel like that's a really good idea for solving that problem too.
I I don't know if you ever read the news article where like I know we're running out over time now, but just like a data center moves in and then all of your like electricity and like water costs immediately go up by like 3 times. Um,
Well, I was watching something where they were also talking about how they'll lobby that they're going to invest in the local infrastructure and they're going to improve the
yeah.
water infrastructure and they're going to improve the electricity. And then you look at where they're proposing. It's like you can't improve
Nah.
the water infrastructure when there's no water there in the first place.
Yeah.
I think this was they were trying to build one in Arizona. It's like there's no water there already. What are you talking about?
Yeah, I know in Tennessee it's like a lot of the companies will claim that they're gonna build nuclear reactors, like that's the future, but then it's just like no, it's just all natural gas. It's just a
I mean,
bunch of
isn't it still a joke if you're going to nuclear engineering that you may or may not ever be involved in actually building a nuclear reactor? Is that still a thing on campus? Because I remember the nuclear engineers were a little bit of a
I think the
how
the
much bureaucratic nonsense they're going to have to deal with, sort of thing.
yeah, I have a friend who used to work in a space like that, and I think his options were to join the military or or go to a country that actually has nuclear programs that do, like Japan or France. So
It's really sad too, because I remember hearing some of the nuclear technology that was like cutting edge back in like 2014. It was like, oh, well, we'll never have another Chernobyl if they implement this stuff. And it's like, well, because they fixed all those problems, but they can't actually get the approval to put any of them in.
Yeah.
It's like, what are we doing?
Yeah, welcome to the future.
Yeah. So
I'm
I've never
guessing. Sorry, go ahead.
no, go ahead. I was just gonna say I've never heard of them promising to build a nuclear reactor. I feel like that seems like excessive promise in the United States.
Yeah, there's a couple CEO interviews with like Sundar Pichai and like Elon Musk and so forth. Or yeah, or the I think Satya Nadella was also talking about it. Um, it is 106 guys. I don't know. I think you guys are doing this on your lunchtime, right? So
Yeah,
I'm happy
yeah.
to.
I'm
Yeah,
5 minutes past my lunch
I
break, so
gotta
I probably
drop
should get
off.
going.
Sorry
Yeah.
about that.
Yeah, thanks for showing up, guys. Yeah, take care. Yeah,
Yep, good to talk
Yeah,
to you.
bye.
yeah. See you next week.